from that work. I think it's finishing the top of the yellow.
Nice. Yeah, I love the quality on these, man. Like, this is... pretty cool. It'd take a long time to, you just like glue it together?
No, actually glued together real easily. Basically, like this upper section is just four sides. And they just glue together, and then there's a little top piece, and then the top piece on that.
Nice.
Same with the lower sections. Basically, four sides go together, glued on with that base in between, and then you put the railing up, and that's it. I didn't, for transport, I didn't glue.
Yeah.
So it's really, you know, it's not that many pieces, that project.
So does the crane actually function? Or?
The design, the guy never built this design. He designed it. I bought it from him off of an Etsy account. It is a lufting crane, so the boom will go up.
Oh, that's cool, man.
Down. It should do it by these gearing down here. Yeah, the gearing and stuff should make it do that, but it's a round hole with a square peg in it, and there's just too much binding in the gears and the
yeah.
So I'll probably redo that and put some brass tubes into the wood and, you know, and make it, put a little drop of oil on it and make it where it'll work.
Maybe some like Teflon tubing or something.
Well, I just get two brass tubes, one that fits inside the other with a tight clearance.
That's cool. Yeah, so it's pretty much a gantry crane, or?
It's actually called a lufting crane.
Lufting crane?
Yeah, and it's used in places like shipyards and manufacturing because it's on rails.
Yeah.
And so it can travel alongside the dock.
That's nice.
Or the dry dock. It can travel up and back, but it's that's what that is.
That's cool.
The Caterpillar shovel there is from the same guy that I bought this plan from. So that's all plywood also. The only difference is it's painted.
Yeah, so it's all laser cut?
It's all laser cut also. Laser cut and hand painted. I decided I wanted to practice painting, so there's a project.
Yeah. So how long did it take to build something like this?
Basically, I say this tower crane took a couple of weekends to cut out and about 3 weekends to assemble. The shovel took me a lot longer because of the painting.
Yeah.
I also take a lot of these parts with me to Makerspace and just sit down, talk to people, and assemble a little bit or paint a little bit. You know.
So, is there any challenges like on the crane, like I don't know, like bringing it here to Maker Faire, you know, like stuff breaking or?
Didn't break it. You see that blue styrofoam over there?
Yeah.
I built that. This will actually sit inside of that.
Nice.
So I protect that, and then I just lay it on top of the boxes that are carrying everything else.
Nice. What's good, man? So you're with Makerspace?
Yep, over in Leak City. Come by on a Tuesday night, 7 p.m. We open house. We'd love to give you a tour.
Okay, cool. Thanks, man.
See, that's about my limit of liability right now. I can't afford the $250,000 red epic to put on there.
Yeah.
That I can afford. 12 years old. It's been built and rebuilt several times.
Yeah, it's cool, man. You designed that?
Yes.
Nice.
Flies an Arduino Uno, or actually the Arduino Mega, because the computer programs it.
So, yeah, I like your toolbox quadcopter. Oh, man.
Doesn't have to be rocket science. That's my Home Depot drone.
Yeah. Hey, how does it fly?
Like a toolbox. It was not designed to fly. It flies like a toolbox.
Yeah.
I mean, if you want to go fast and you want to have fun, you buy the racer and you fly that. You know, if you're doing just general drone work, you fly something like that. And essentially all it is these are the parts that a DJI Phantom have inside it.
Nice. So does this come like in a kit or?
This used to. The company that makes this isn't in business anymore.
Okay.
Which is the sad fact of drones.
Yeah.
The business is coming.
It's a competitive market out there, yeah. Absolutely
gorgeous frame. I love that stuff. It's called Guy Bond.
Yeah.
And it's absolutely
fast is something like this?
That is actually software limited to 500 meters of range and 150 meters of height.
Okay.
But like I said, it's designed as a cinema class camera. It's designed for 2 operators. You have one flying the drone, one flying the camera.
Is it tricky to set up the firmware?
Not really.
With all the props?
If you've ever done anything with a drone before, it's the same basic logic, just broken out into 6 motors instead of 4.
Yeah.
You know, there's a little bit of, instead of breaking things out into a quarter, you're breaking them out into a 6. So instead of dividing by 4 to send to the motors, you divide by 6 and send out to the motors.
Yeah.
That's all it really is. The math doesn't become that much harder.
Yeah, this is kind of like a helicopter, drone, quadcopter hybrid kind of? Or?
Well, it was a Scorpion frame. Really, there's functionally no difference. This is called a coaxial 6. It's 6 motors on a coaxial on a Y. There's functionally no difference between that and the radial. The flight times are exactly the same because this is lighter, but there's turbulence between the 2 blades.
Oh,
so you lose your efficiency in your motors between the 2 blades, but it's lighter, so it flies the exact same amount of time.
So what's the benefits of having
it looks
dual?
Cool.
It looks good. Yeah.
That's it. Think about Terminator 2, the wind tunnel.
Yeah.
General flies up behind it. We built Skynet.
Nice.
That's it right there.
Nice.
We get a lot of our inspiration from the movies. The movies get a lot of inspiration from us.
Yeah.
That's my failed BB-8 project.
So all this is at Creator Space?
This is all in my garage.
Oh, okay.
These are all my personal toys. I just bring them out to Creator Space because it's a lot of fun.
Spider-Man and Maker Faire. So what kind of printer was this printed on?
It was printed on a big rip, and so it actually could print the whole propeller as one.
Oh, nice.
But we printed it in sections, so it's actually like 5 sections.
Yeah.
And it makes a bigger propeller. The big rip can do the...
Yeah. The bigger rep's the big orange printer, right? Yeah, that thing's huge. So what is this? Nylon with carbon fiber in it?
Right. We have carbon fiber, continuous carbon fiber inside here, so it makes it very, very strong. This is stainless steel, and we're working on Inconel, titanium, tool steel, copper, aluminum.
Yeah. So they can do Inconel and all that in the FDM process?
Yeah.
That's cool. So what they do actually, is it molting, molten steel, or is it,
No.
It's embedded into like a filament?
It's powder in a filament.
Gotcha. Kind of
So
like.
then we can get it to flow at just 250 degrees.
Yeah. So it's something kind of like.
So it creates the basic shape.
Yeah.
And then we put it in the oven, it goes in, and then all the resin disappears and we're left with the strong stainless steel part as one.
Nice. It's kind of like something like desktop metals.
Yeah, desktop metals.
Yeah, right.
They use like nails in theirs.
Yeah,
We use filament.
Yeah.
And ours isn't as big and as bulky. We have a much simpler process, but very similar. Yeah.
Yeah.
Desktop metals.
Nice. So, what's the name of your company?
ImageNet.
Okay, so y'all are a contract.
We sell
for
3D
hire.
printers, all different, whatever your need is. We can say that metal printer or that basic printer, school printer. But then we also print, we also sell
Bags.
What?
Bags?
Bags.
You're pointing at me. This is for you. Thank you for sponsoring me, man.
Wonderful. Great. Excellent. Wonderful. So much. Put that picture on my wall.
All right.
So y'all got a whole range of.
Yes. Yes. So we do resin printers. So now we can print with very high detail, like
Nice.
you need when you do dental work,
Yeah.
or when you're doing jewelry.
Nice.
So
nice.
with resin, we get high detail, and then in some cases, this is with the casting material. So then I can cast this in the metal I want it to be.
Nice.
So, but it does wonderful prototypes, very fine detail, just a great clean.
That's cool. Is that like a rearview mirror? Or
Yes, it is. It's a rearview mirror.
Cool.
And then we can print in resin printing. That's like flex material. So now we can,
Nice.
So we print products. The doctors will print a heart out so they can practice or see ahead of time before they go and work on their patient.
Yeah.
So we work with prototypes, but we also work with strong working parts.
Okay, so y'all sell printers and you 3D print stuff for...
Right, and we service printers.
Okay.
So a lot of the schools will buy a printer from us because they can get a service contract or they can lease it.
The leasing the printers is such a good model too, because with the school system, they're pretty slow. And basically, it's easier to get some kind of subscription-based payments, or
Right.
than actually sell printers. It has to go through an approval process.
Correct. And sometimes it's easier for them to lease it.
Yeah, because originally that's what I was going to do, is sell printers to the school system.
Right. Well, we got started in the typewriter business, and then a big part of our company is we sell copiers and printers. So we sell HP, we sell Konica Minolta, Ricoh, Canon, and so although all that stuff is 2D printing, it's logical that we would do 3D printing also.
Nice. So this is done on a 4200 series HP. So how do you like that HP printer?
I love it. It's got a great big build volume. I can print 330 of these all in one printing.
Nice.
So it is a production 3D printer.
Yeah.
Whereas these are kind of prototyping. Now I've got a machine that can produce.
So like on the HP printer, like what's your range of materials on that?
Well, we're limited to just one or two right now, but they're working on everything from, all the exotics up to metal.
Yeah, because I remember when they first came out with it, they had a big demo, and they 3D printed a chain and lifted a car up. I don't know if you remember that. It was a big deal when HP got into the market. They said they were going to get in the market for a while.
Yep,
It took them a few years. I heard Canyon's getting in the market too.
Yep.
We're Team 12364, and we represent the Early College High School First Tech Challenge team.
Nice.
Yeah. And
So y'all fight these robots, or?
No, we have a competition
Yeah.
that we have to complete.
Oh, okay, like moving blocks and
Yeah. And so
That's what the real competition.
And so this year's challenge is Rover Ruckus. And so what they have are different tasks which are optional and depends on what you want to do. So for this year, we designed our robot since there's a weight limit of 42 pounds, we made our robot smaller so that it will be faster as well. And then here, so since after reviewing the scoring sheet, we found out that the best way to maximize our points in the competition was to they have this little lander thing where you have to latch on at the beginning and at the end of the game. And so we designed this thing to where once we get the motor running, it should like go up and down and then latch on to that lander and then lift itself up to score points.
Nice.
And so this lander here can earn us a total of 80 points during the whole game.
Nice. I like these gears.
And then in addition, what we plan to have later is an arm extension to collect the little blocks to score other points too in the competition.
So what are the design challenges on something like this?
Oh, design challenges? Okay, first of all, one of the challenges is that we're supposed to be lifted up 4 inches off the ground if we want to gain the points. But we have to add more weight to the front. So we have to take away more weight from the front so that it doesn't go like this.
Oh no, sorry, but yeah.
So we don't want it to lean more to one side and then be 4 inches on
Because one of the issues that a lot of teams had last year was that because they didn't balance out the center of gravity, the robot actually flipped back and then they were just out of commission for that entire game.
Yeah.
And so we were planning to put an arm in the front to balance it out later.
Nice. So these wheels, they're designed so you can move sideways.
Yes.
Oh no. Since the wheels that can move sideways are heavier, we decided to discard that and use these wheels instead.
Nice.
So we can't go sideways, but we can at least turn.
Yeah.
So do you have any other questions first?
No, that's it. That's good, guys.
Thank you.
I don't think so.
Let's just do that right now.
So what do y'all use for like the motion controls?
For motor controllers,
Yeah.
so we've got Sparks. We mostly use pretty much just Sparks. We've got a couple.
So what is that, like a relay or something? Or?
What motor controllers are those? That are Sparks. Vectors. Vector.
Sorry. They should be anyways.
What about these right here? The servos?
Those are regular. Those are Sims. They're a drivetrain. So and they're connected to gearboxes, and we've got
100 to 1, I believe.
Oh, okay.
Right here.
Yeah, the gear ratio.
And then these are bags. They're there's one in between this size and this size called a mini sim. We don't use those, but these just spin these.
Oh, nice.
They're separated so they don't spin together.
yeah.
Oh, okay. Yeah. So you got them independent.
This is our
So what are like the design challenges of this?
So we had to intake.
Just leave it there.
honestly pretty much everything about this robot.
Yeah.
Key challenge.
I guess y'all come up with a concept and then try it out, and then there's stuff that doesn't
Lots
work.
of prototyping, like 3D printing stuff. Like
Yeah,
wood.
yeah.
Not 3D printing, laser turning out like wood and stuff. Yeah, so these wheels spin, they intake the cube. Decides to go in. And then this servo right here can lift it like up and down like that. It can go up to 90 degrees.
Yeah.
We have that bar there to stop from going farther so it doesn't mess up our electronics. And then we can shoot it into like a logo that's like this tall, and there's a little lever on it. The goal is to have more cubes on your side so it's tilted down. And also there's just a little like spot that's just a little bit bigger than this that you can put it into and get like power-ups and stuff.
Nice. So the brush, what is the brush for?
So we don't have it with us now, but we had
It's
a
under
hook.
the table.
Oh, so it goes up and we have, sorry. So there's another metal bar that goes up really high here, and then there's another one that comes down. We have a hook here. This holds the hook next to the robot so it doesn't go rattling around. Yeah, and it lifts up at the end of the match, and there's like a little rung you can climb on. Yeah, so here's that. So it would usually like sit in here.
Just to prevent it when you're driving around.
Because with this thing, it's pretty fast. So we keep it there so it doesn't like mess around.
Yeah.
Because if you like break another robot with this, it's penalty points.
Yeah.
We use the other half of this for scrap metal.
So how does it work in the competitions? You have to design a robot every semester?
Yeah, so every single year there's a new game. We have 6 weeks to build it. This year it starts on January 5th. Usually starts around there, just right when kids get back from winter break. And we have 6 weeks to design a robot. Everything, we don't get any kit, like no parts.
Yeah.
Everything we have to fabricate yourself, design yourself, except for like chassis and wheels and motors. But other than that, everything is like all this. We remake a new electrical board every single year, completely. Sometimes the chassis is completely different sizes.
Oh, y'all make y'all's own electrical board?
We buy the pieces individually, but yeah, everything is rewired every single year. So I think the only thing we reuse are the Robo Rios and our like radio and a couple of like.
And the power distribution panel.
Yeah, but everything else, like if something breaks, we like always make new ones. So every year it's completely rewired, like a different amount of motor controllers for how many motors we have.
Yeah, I like y'all's system right here. Just keep it simple. You don't really need motors for that.
Yeah, some robots,
hold on, is that?
No, it's not.
Oh, okay, that's just idle or kind of. Or?
Yeah, it's just a tension.
Yeah.
some robots use pneumatics to hold together, like they can open and close it, which is efficient but hard.
Yeah, you can have it. You can have it. Okay. If you want it, you can have it.
Cool. Looks good, guys. Yeah, so what we're doing with this machine is basically we want to have more than just a printer, more like a digital manufacturing center. So we got
Making parts to make parts.
Yeah, well, it's not just printing plastic. You also put a CNC spindle on here.
Yeah.
So the CNC spindle will mount right on the other side of the carriage. Also, one of the things we're working on is actually having like a chocolate extruder, a clay extruder, 3D printing different materials that aren't just thermoplastics.
Right, right.
So another thing we're working on is actually 3D printing with epoxy. So you have your normal FDM process.
Right.
But what you do is you design the model so it has like cavities.
Sure.
And channels through it.
So you have, okay.
So what you want to do is evaluate the part, the functionality, and so this is more in line to 3D printing like functional parts, that are actually useful. So pretty much you do design the model, figure out where the weak points are, where you need to strengthen it up, and you print the model, and we're gonna have like a little plunger tool, like a little. So it's gonna have a little injector tool, like right here.
Yeah.
And this whole thing is modular. We got a bunch of little tapped holes on the side.
Right.
But so injector tool comes down and it'll eject epoxy. And you get reinforced epoxy too.
Okay,
like
yeah,
glass
right,
reinforced.
right.
And,
That's a novel idea.
one of the benefits of actually having like epoxy and other types of resins is a lot of different types of plastics don't really bond too well together.
Right.
So you can have bonding issues with multiple materials. So what you can do is if you design everything in the model right, you can come down and reinforce everything with some type of resin,
Sure.
like epoxy or whatever, and it'll actually hold everything together.
Right, right.
We're also looking to put a pick and place arm on it also.
I've started to see more pick and place things start to show up that a few years ago there were people trying to do it and they were kind of cumbersome and they just kind of died off, and then all of a sudden there's interest in them again.
Yeah. Well, when we designed this, we were thinking, where is 3D printing going? Is it going to actually evolve and spin off into something else? And so, we're thinking more on the lines of like a whole digital manufacturing center where basically, you have your basic 3D printing process, and then you have other tools. You can pick and place arm, a CNC spindle, and some kind of injector tool or whatever. And basically, you just manufacture, a complete working part.
Yep.
Embed electronics in it. I mean, they have conductive filament, so you can actually 3D print circuits. I even seen. I even seen filament. It was like magnetic filament, so you actually 3D print magnets. Now, there was a company, I forgot the name of it. It came out with it. I haven't read. That was a few years ago. I haven't really seen anything about it since. But they had magnetic filament, and they also had filament where you actually 3D print batteries.
Batteries.
Yeah. So you had the battery in any shape. Now I don't know how efficient it would be.
Sure, but still,
Yeah.
the idea that you could create a battery to fit a unique shape is almost a solution in itself.
Yeah, exactly.
I mean,
Especially if you print it like a flexible battery.
In fact, the available space you have, you probably can't fit enough batteries in it to give you what you need, but if you could print one to fit there, maybe you could get close to the capacity you actually need.
Yeah.
The concept there, that is, wow. What kind of material do they use for the batteries, I wonder?
Dude, I don't know anything about batteries.
Right.
So.
Yeah, I mean, there's just...
It's a start. You can see where everything's going.
Whatever they start with, somebody else is going to go, you morons, don't do that, do this. And it's like, okay, well, we didn't know that.
Well, you start 3D printing circuits and batteries. I mean, you open the doors to all kinds of.
Somebody else will go, well, I never thought of that. Hey, well, why don't we go do this? And sure.
What I'd like to see is 3D printed motors, like actual operating motors. So if you have conductive filament, they even have what's it called? Not carbon fiber. Oh man. I forget the name of the material. It's a new type of material they developed.
It can take heat and hold its shape.
No, it's like it's really strong and really conductive.
Okay. Oh, okay.
Yeah, I forget the name of it. It's got some weird name.
Sure.
But yeah, so you know they have some really conductive materials outside copper. So I was thinking if you could 3D print, you know, if you got 3D printed magnets, you could actually 3D print conductive spiral, you know?
Yep.
So like some kind of helical structure, and 3D print your magnets and everything. You have a working motor, you know?
They've got motors now that some of the windings are PCB printed and the magnets are flat and sandwiched together and they almost don't look like motors.
Yeah.
But they are. And they're very thin.
Especially if you can change the shape of the motor, you know?
Yeah.
I mean, you've been making motors for a long time, but you start making motors embedded into objects, or you're not limited to geometry constraints. The motors, it opens the door to other applications. No telling what those applications will be, but
whatever someone's imagination can do.
Yeah.
Cool, thank you.
Yeah.
Sixth time.
Is it?
Now is the sixth time that we changed the.
Yeah.
So first time
I guess when it breaks, you know, you see like what the weak points are and design around
this
it.
model is second time. Oh, okay. Because first time is I don't think so. Second time is that for children or? Yeah, for children. And speaker.
So right now, no, we're not looking to get to metal. So we started out and using some products from our
How did you hold it? I'm left-handed, so I don't know how to. How do you hold it? Left. Or yeah, it's right.
So what kind of printer did y'all use for that?
I believe she used filament. And it was printed from a 3D printer called Object, LX330 or something like that.
Oh, okay. Nice. So what does the buttons do right there?
So you turn it on.
That's cool.
There's a play button. It's going to play. It's volume up.
Nice. So did y'all design these? Did y'all design these?
She did.
Nice.
Chick right here. You can put in, you can play any song, you can connect to USB, or you can put in you can connect to Bluetooth
Oh, nice.
on your phone.
So do y'all sell these?
Yes. This one and that one for sale right now. This one's not for sale.
So how do you buy one? You got like a website or?
Not right now. They don't really have an official website or anything, but you can visit her Instagram or you can email her.
Yeah.
They just started this within a year.
So we changed the design, so more similar the original violin. So feeling the more violin condition.
Oh, okay.
Yes, we have printed furniture.
We very detailed things. We possess
Furniture yet with our
really original violin. Inside, they have a sound post. Yeah, because sound post very important things is the sound.
Yeah,
Yeah,
but the
yeah.
acoustics.
Yes, acoustic sounds. So we make
The seam design team hasn't finished the grinder yet, so no, we haven't.
Nice, nice.
and up and
That system
this
is not
and this
To help it
more the
echo out.
yeah. First time we didn't build this one, but sometimes over the high degree the
Maker Faire will have at least a full work.
put the break.
Okay.
So we more change the more hard.
Oh.
So you have like a Arduino in there? Or?
This is the just Bluetooth, support the Bluetooth system, but after that maybe last
Yeah, we've done
December
a little bit with
we make just one more device. We developed the device.
Okay, so it's already everything will be on there.
Everything.
Okay.
So
found that if you add just a little bit of color,
really body is 3D printer, but the fingerboard is we made.
very large section of the
But I think this violin is very special because first time we for the imperial, I think
I don't think there's any color changes left in that part. I think it's finishing the top with yellow and it'll be done.
Nice. Yeah, I love the quality on these, man. Like this is, you're getting some really good prints on this. That's beautiful. So you just print with like mostly PLA? Or-
No, it's almost always ABS.
Oh, okay. That's even more impressive.
Yeah, ABS is just a more practical material for actually making things that
Yeah.
more durable.
You get sand on it without it
And you
melting.
you can glue it together better than PLA. We print a lot of the parts in the printer. It's like ABS. All the blue and yellow stuff, all the black stuff is all printed.
Yeah. Well, originally everything was printed, right? Or I was talking to one of the guys the year before last. And, is this still printed?
Yep.
Yeah.
Yeah, it's never been justifiable to us to get the molds done.
Yeah.
You know, a couple $100,000.
Oh yeah, I guess it's expensive. Yeah, that's pretty cool. To actually 3D print that.
It's done.
Nice. Yeah, that's beautiful. And this one's using the Duet Wi-Fi too, right?
It's the Duet Ethernet.
Yeah.
So here's a little flaw. It's got a little nib sticking out of it. There.
Oh yeah. Typical.
Yeah. This saves all the actual nibs that would have been on there.
Oh, okay.
You know.
So that kind of purges it, or?
Well, it does a little prime and purge, and it wipes the nozzle. But in the time the nozzle travels over, it's already got this length of nib sticking out. This cleans that off, make sure everything's flowing right. Then it goes right to the part, like it's right next to it. So then it comes to the part clean.
Nice. Yeah, that's absolutely beautiful. I haven't tried the Duet Ethernet yet. Is that pretty similar to the Wi-Fi? I mean, it's like is it the same interface? But
It's like
yeah. Oh, cool. So you got a little purge catcher right there.
Yep.
Have you seen have you watched any of those E3D videos, the tool changer? Yeah, those are nice. They got the little wire brush to the side. It comes in and it wipes it.
Yep.
Yeah,
that's really neat stuff.
So what kind of coating or what kind
It's
of?
just pet tape.
Nice, nice.
It lasts a fair number of prints. You get a couple weeks out of it, depending on whether anybody scrapes it up with the scraper or not.
Nice.
I can see why they want that done.
Just uploading another V20 with less info.
So how long y'all have been in business for?
6 years doing the printer stuff. 6.5.
That's cool. We're right out of Dallas, Texas.
Just south of Dallas, yeah, middle of it.
What was your travel about 16 inches or
this is 18 dual printing area by 9 by 9 like 9 high 9. The other printer is 999
so these are like your main 3 models or
we have a
these two are the same right here.
The same. We have a 20-inch printer that's single head. And the dual is 18 because it has more. It's got the buckets and.
Oh, okay. 20 by 20 or just 20 inches?
No, 9 by 9. 20 by 9 by 9.
Nice. Yeah, it's definitely a beautiful printer. I think it just works too.
Yeah, generally. Falling weight on the step. So a lot of people use some pretty coarse rods. I don't agree with that. So.
Yeah, the first printers I built had really coarse rods and.
Sorry. I haven't bought a 3D printer yet because my son had a project and just went down to the library.
But he's mentioned Christmas 3 times.
But I want it. But I want one. I just don't need one. But the one that we were looking at, just from people we've been talking to, was the one that was made by it's an entry level machine, but I was wondering how does that compare to poly printer?
What kind of filament is this right here?
That is just
I think it might have been you. Somebody yesterday was, man, they were taking some turns.
Oh yeah, it's me. But the other guy doesn't have to slow down the turns. He got me a couple laps.
Yeah. So what's the longest print you've done on this?
I know that we've had customers printing for like 2 weeks straight.
That's pretty impressive, man.
Yeah. I don't know.
That's impressive in electronics too.
Yeah, so I mean, for me, I've probably gone like, I don't know, almost 200 hours or something, but when you're at 2 weeks, you're like 300.
Yeah.
300.
I think the most I've had my printer going for 7 days straight.
Oh, yeah.
But it was separate components, so like, it'd print for a couple of days, it would stop, but the printer would stay on. I had it scheduled out, I had an alarm set, so I'd get up at like 4 in the morning, take the part off and hit print again,
nice.
you know, something like that.
Nice. The production grind.
Yeah, but I had a job I had to get out, you know, for a customer. But like this right here, like how long would something like this take?
This one took probably about 3 days. At least for the big, you know, the main roller coaster part. And much less for the little elevator. That's much smaller. Yeah, about 3 days all total, I think.
That's a great demo part.
It really is. Nice and
Yeah, this
interactive.
stuff's pretty good.
Yeah. It's fun to play with.
The skateboard, I really like the skateboard, Jay. It was like Pet G or something, or ABS. Oh, y'all did that on the pellet extruder, yeah.
Yep. Yeah, so it broke, unfortunately. We took it to too many shows, too many people riding on it.
Yeah, yeah, I bet so.
Yeah, and they're like, one guy just like stood on it with both his legs together, and that just. But I mean, it goes to show like it's not good for everything. I liked the PET because it was nice and springy. It's like more flexible than PLA. If you made it out of PLA, it would just be like a rigid board.
Yeah, a lot more robust too.
So this rode nicer, but you did have that risk of like if you bend it too far, it's just gonna snap.
Yeah, yeah.
So that's what happened.
The fill mixture is really awesome. So.
With this, we're just really trying to validate the printing process for the pellets.
Yeah.
Making sure that we can have something that's really reliable and can switch between different materials as well.
Yeah.
So that's kind of what we're aiming with this. We had a good prototype with our Kickstarter that was quite a bit shorter. But the issue we were running into that was that our compression ratio was a little bit too high. It was like compressing all the pellets a little bit too abruptly, that would require tons of torque from our motors.
Oh yeah,
so we would
EVO 23 or
so we run into
reduction
issues
on it.
Yeah, we'd run into issues where the motors would stall out or something.
Yeah.
If you're trying to print too fast. So the longer screw gives us it allows us to run it with less load on that motor and a little bit more gradual. Melt.
So do you have to get the screw hard? Is it like hardened steel? Or, I mean,
I think so. Yeah.
Yeah, because I guess some of the filaments, are abrasive.
Yeah, right. So we haven't ran anything that's like necessarily that abrasive through it quite yet, but we do have the intention of like putting in some like carbon fiber composite pellets or whatever. Through it. So yeah, in that event, like you do want to make sure that inside is going to stay nice and hard.
That's cool. So like the nozzle, what kind of like nozzle diameter?
So that's 1.75 millimeters. So I think they might have taken the design off of one of like a filament extruder or something and just like use that.
Yeah.
But yeah, so that lets us do like really nice and wide extrusions and really big fat layers. I mean, you can see that on the.
So which one? Okay. So this is printed with the pellet extruder right here.
It's 100% recycled PET.
Yeah. And the cool thing about the bigger bead is actually stronger.
It's really strong, and then you can print really fast. So I mean, this thing's like a really massive extruder component. So we do have to kind of slow down the actual speed of the printer, but our material output is still so high that we can get parts done like insanely quick.
Yeah.
So a board like this, it only took us a couple hours to make.
So you guys slow down because the moving mass.
Yeah. If you don't want the artifacts and stuff.
Yeah.
But I mean, that being said, like the parts are so low fidelity anyway, just from having such large layers and all that. Like, it's kind of like up to your judgment, like how much that's really going to affect the final product. So yeah, I mean it's still ongoing. Obviously, like we still have quite a bit of testing and refining to do. Not recently.
Man, they're doing pretty good on it, man. Like the quality of prints they're getting is crazy. It doesn't look like a pellet extruder. It's ridiculous.
Yeah, I haven't seen any of those printers before. I've seen like 3D platform at one of the shows we've been to. They had a printing machine out there, which is pretty cool.
Yeah, I got a giant base from 3D. I was printing on a 3D platform. I went to the Rapid event in Dallas, and they had like these giant bases. And they're like, it's like, I don't know, 20 inches tall or something. Yeah. They were gonna throw them away. They're like, man, we printed all these vases up. Does anybody want this? I was like, yeah, I'll take one.
Yeah, there you go.
My wife's like, why don't you just print one? I was like, I don't know.
Yeah, you get that novelty, right?
Yeah.
I'm sure they just like bang those out like super fast.
Oh yeah, yeah. You know, the 3D platform, I wasn't too crazy about it. Like when I first saw the design, because it looks like it'd be slow. It's kind of set up kind of like a router. Yeah. But actually, the prints they get on, it's pretty nice. Yeah. I don't know what their max speed is, but
yeah, they get pretty good stuff. It's not a bad product at all.
I thought those are 3D printed business cards.
Not quite. Maybe one day.
Yeah, I knew somebody who was 3D printed business cards.
Yeah.
Yeah, it actually came out good.
I thought about it, but I don't know, like, at what point we're going to be like 240 showing up with all 3D printing.
Yeah, yeah.
Yeah, so the largest size is 3 foot cubed. This is a middle-sized machine, so this is our Gigabyte XL, which is 24 wide, 30 long, and 24 tall. Nice. We have one size smaller than this, and we have also this machine that does 3 foot tall, so that's our XL.
Yeah. So what's the challenges on printing like 3 foot? I mean, like,
there's lots of challenges, especially when people start looking at support material. If you don't have substantial enough support material, if the machine is not rigid, you're going to get a lot of vibrations in it. So you really need to look at having a metal frame machine anytime you're doing a large part or a tall part.
I got you.
Yeah. We actually give away badges to our customers for print time. So when people do like a 24, 48, you know, we do it a day at a time. And we have customers that are doing prints that last up to 12 days.
12 days?
12 days straight without stopping.
That's pretty good, yeah.
What's really cool too is with the new software that we've got for Gigabyte, we have a feature called endless printing. Because it's a dual extruder, I can load up 2 15-pound spools, and when it finishes one, it automatically switches over to the second and keeps going. Doesn't miss a beat.
That's cool, that's cool.
Yeah,
it definitely comes in handy.
And then you can come back and put a fresh roll on there, and when it finishes that, you'll switch back to the first one again.
Nice. So the pellet extruder, does the pellet extruder come on this version, or you can just put it on any machine? Or?
So there's an upgrade kit available for Gigabyte. So you'll take the head off, you'll take the print head off, and you'll swap out this rail for a more heavy-duty rail, and then you can adapt the pellet extruder straight to the standard Gigabyte frame. So you can put it on a regular XL, XLT.
Yeah.
And you can print with pellets for a fraction of the cost.
Oh yeah.
And you can print bigger things faster and cheaper.
Yeah, you get more of a range of materials too.
Exactly. Not everything's made into filament.
Yeah.
And then what does it look like when you start mixing in the hopper? A little bit of this palette, a little bit of this palette. So you can do color, or you can do chemical formulations.
That's pretty cool.
Dry mixing right in the hopper.
Nice.
Yeah.
So y'all got a heat bed on this, or?
Full-size heated bed. In the enclosure, it'll go up to above 125 C.
Nice.
Yep. And we've got the print and Z material. It's a peel and stick surface for the print surface.
So what kind of material is it?
It's called Print and Z. It's the trade name. Yeah.
So y'all have y'all's own proprietary software y'all developing?
No, it's open. It's open source. So we use. You can use Slicer or Cura. The firmware is Marlin.
Yeah.
And you can download that off our website. And then we generally use Simplify 3D. I really like the software. It does a good job.
Yeah.